Hello, welcome everybody. I'm Will, one of CK-12's resident science nerds, and thanks for joining me today. We're going to talk about some science. First, I wanted to apologize for last time I was up. Didn't really have a great setup to show you guys what was going on, and I got some feedback from you that you really wanted to see what was happening with the demonstration I was doing. So I've spaced things out a bit better. We can kind of see what's happening now. Unfortunately, we're not going to do really an experiment today, so I apologize for that. But next time, it'll be here. So today, I want to talk to you all about combustion. Combustion is commonly known to us as the reaction that produces fire. It's been a critical thing for humans to discover. It allows us to make heat and light, and it's a huge driver of technological advancement. And we often know it as, like you'll see it in candles, campfires, fireworks even, are all great examples of combustion we see in our daily lives. So let's look at the example of a candle. So I guess it's kind of an experiment, but really I'm just burning stuff. So a candle is a type of hydrocarbon combustion. So in this case, we're combusting a hydrocarbon, the wax that this candle is made of. And if we add some heat, if I can get this to go. So by adding some heat to the wick in this candle, we can melt some of that wax and allow it to start reacting. So what's happening here is the heat is melting the wax around the wick, and that melted wax travels up the wick and can then be combusted in the fire. So actually the fuel here is the wax, the hydrocarbon we're burning. Let's look at the same reaction in a CK-12 simulation. So just gonna jump over here. So let's take a look at, so let's take a look at our Campout simulation. So our camping simulation talks about chemical and physical changes. These are the difference between something causing a physical change, which would be just rearranging the substances in something, versus a chemical change, which would be like converting something to new molecules, converting one substance to a different substance completely. So if you go camping, you have a lot of chances to see these different kinds of chemical and physical changes. You might be like filtering water or melting butter to cook with, even looking at like how a flashlight generates electricity. But we are going to look at our we are going to look at wood burning here. So in the campfire, you're going to use wood as fuel quite often. And wood is made up of a substance called cellulose, primarily. There's a lot of other stuff in wood, but a lot of it is cellulose. Cellulose is a carbohydrate. It's like sugar, a slightly different structure, but it's made up of carbon, hydrogen, and oxygen, as you can see down here in the chemical reaction. Yeah, so when we apply enough heat to wood, we can break these molecules apart and allow those molecules to start combining with the oxygen in the air. So here you can see the oxygen around the cellulose. Cellulose heats up enough to allow the oxygen to combine with its molecules, and then they all snap together. And we create the products of combustion here. The energy we see released as heat and light comes from the difference in the energy of the products versus the energy of the reactants. So in this case, a lot more energy is released by the bonds breaking in the reactants, and a lot less energy is consumed when you make the new bonds in the products. So you get a net release of heat and light. And this heat and light goes into the rest of the fuel, some of it, to continue the combustion reaction. And the rest of it is released into the atmosphere as what we see as heat and light. Remember, don't play with fire at home. That's why we've made these great simulations for you. So I encourage you to come and check out the campfire simulate or the Campout simulation. Get a better idea of how that works, and just oh dear. Suppose you may have been looking at my keynote the entire time. Sorry about that if that was not the right window. Still working out this whole digital world thing that I'm not so great at apparently. But anyways, let's take a look at what CK-12 has to say about combustion. So combustion reaction, as we can see here, is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of heat and light. So combustion reactions must involve O2, oxygen gas is one reactant. It's very important that we're talking about oxygen gas and not just any kind of oxygen. It has to be oxygen gas. So here, let's look at a couple different reactions here. So I've got a reaction. So the first reaction is something we're more familiar with. So this is a hydrocarbon combusting. So we've got methane, CH4, which is usually a gas in standard conditions, and it's going to react with oxygen. So when you heat it up enough, it'll react with oxygen. In this case, it's going to produce carbon dioxide gas and water as products. And you'll probably notice that each of these, like I said before, each of these reactions contains oxygen as a reactant. Bonus points if you can figure out what the common theme between all the products are. So hydrocarbon combustion is what we'll be most familiar with in our daily lives. But it's not the only form of combustion. Combustion can even occur with a single element and oxygen. So if we look at our second example here, the combustion of hydrogen gas and oxygen gas, all we produce here is water because there is no carbon present in this reaction. There's no way we can make carbon dioxide, so our only product is water. This is probably more accurately going to be a gas and not a liquid, as I've indicated here. So this is why you often will miss it, because you burn, even in the case of hydrocarbon combustion, you burn your hydrocarbons and the water just escapes as a vapor and you don't even notice it was there. The third example we can talk about is the combustion of magnesium, which is actually a solid metal. So I've got some magnesium here, and as much as I would love to put this in the candle and burn it up right now, that would be exceedingly dangerous because I am in a very small apartment and I would probably lose my deposit. I don't want to do that. So it's there, we're not going to actually burn it. But the combustion of magnesium is the same thing. You heat up magnesium gas or magnesium metal enough in the presence of oxygen gas, and it will combine with the oxygen gas and produce magnesium oxide. Interesting thing about this is magnesium oxide is actually heavier than the magnesium metal that you burned in the first place. So in this case, the solid product of that reaction is going to be heavier than the solid you started with, which is kind of counterintuitive. Usually we think of like combustion releasing something into the atmosphere, but in this case, it's actually taking the atmosphere and packing it onto the metal and releasing a bunch of heat and light in the process. Let's see if I'm missing anything. So the important thing to take away from this is that when you're looking at a combustion reaction and trying to predict the products, especially if you're like doing questions on your homework, stuff like that, you really have to look at what's in the reactants to predict the product. A lot of times we hear people saying like it's always oxygen, or it's always carbon dioxide and water, or water is always the products of combustion. But you really have to look at what is going into the reaction to predict what's going to come out of it. You can't just make assumptions. And one last thing, please don't play with fire at home. It's exceedingly dangerous. If you really feel the need to do that, consult your parents, make sure they're supervising, because yeah, that can go very wrong, and we would not want anyone to get hurt because of an experiment. That's our main goal, doing safe science. So I think that's all I've got today. Thank you all very much for watching. Thank you all very much for watching. I appreciate you being here. And next time, I promise we'll do something a little bit more fun. Thanks a lot. Have a good day. Bye.